Welcome back to day 38 of LeetCode grind. Solve or go home. 30-minute solve or go home. Okay, so what we got? Oh, count primes. Oh, okay. This one should be pretty simple, right? Count the number of primes less than n. Okay. So I think my preferred algorithm for primes was the sieve of whatever. I forgot how to pronounce it. I don't remember the exact way to implement it, but I do know the general concept of it.
Okay.
So I believe it was okay. So it was you allocate an array, and then you fill in all the multiples. Wait, no, was it multiples? Oh no, it was it was a Boolean array, and then anything. You just fill in trues for anything that's a multiple, and then false for all the non-multiples, and then all the falses are the primes.
I think you have it backwards.
Is it backwards? Because okay, so you.
True or false to tell you whether it's a prime or not.
Oh, say that again.
Is true or false telling you whether it's a prime?
True is a prime. No, true is not prime, and false is a prime. We should probably do it the other way, so it makes more sense. So true is a prime and false is okay. Yeah. So you make a Boolean array allocated at start, and all of them are true, and then you just fill in all the falses for the multiples, and at the end, everything that's left as true is the prime numbers.
Okay.
So yeah. So okay. Okay, it says count the number of prime less than non-negative n. Okay, so n. So I only have to allocate an array up to size n.
Correct.
Yes. Okay. So my Boolean array. Okay, it will be r equals true times.
True is equivalent to 1.
Oh really? Okay, let's do that. All right. 1 times n. That means I'll have up to n. Well, is it inclusive? Count less than. So it should be n minus 1.
Well, I mean, it depends what you want to do, right? Like if you want to access individual indices without changing anything, you can have an extra 0 index.
Wait, why would that help?
Because then the 0 you can throw away, and then the actual index would just be that.
Oh, I see. Because if you do it like that, then you just skip the first index because it's 0. And you don't care about 0, right? And you just go from ones. Wait, is 0 a prime number? 0 is not a prime number, right?
0 is not a prime number.
Okay, that's fine. Yeah, we just skip zeros then. So in that case, this would be a Boolean array of all ones up to size n, and then basically. So we have to store, like if it's, so we loop through the multiples, we loop through the integers, and then we multiply them up to n, and then all those numbers get plopped in, and then we loop through until, as long as they're all, the multiplication is less than n. But okay, so
right.
So it's like you start at range 1, right? So 1 times 1. Wait, actually no, 1 is a prime, right?
Well, first of all, is one a prime number?
1 is a prime, right? I'm pretty sure it is.
What is the definition of a prime?
Oh wait, it's not. Oh, definition of prime is cannot be. Is only divisible by 1 in itself.
Right.
But a 1 is divisible by 1 in itself, right?
Well, itself is 1. So
does that count or no?
No.
Okay. So in that case, okay. So if it's not divisible by itself, so 1 is false, but then. Okay, that's fine. Okay, wait. So my loops should be from 1. Okay, 1 to n, right? Okay, so yeah, there should be one. Okay, I think it's 2 loops. The one is a for loop, and then the second one is a while loop. So it'd be like kind of.
Follow it, but maybe.
Yeah, kind of like a for I in range of 1 to n.
But we don't have to worry about 1, right?
All right, so we can just falsify that. We can start at 2 then, I guess. So then we would need to hard code it then. It would be like r1 equals 0.
And what about a 0?
R0 is also, yeah. Okay, and then I would be, my while loop checks to see if the multiplication is greater than n, and then you would not loop anymore. So it'd be like it would be what do I call it? Multiple. You start with 1. So while I times multiple less than n, r I times multiple equals 0. But then wait. So I times multiple. So first one is 2. 2 times 1 is 2. 2 is less than n. So you do it. So that means position 2 is 0, which is correct. Okay, that's fine. And then while this happens, what's up?
Position 2 is 0.
Wow, say it again.
You're saying 2 is not a prime?
2 is a prime. Oh wait. Oh wait. Shit. Okay, wait. So is 13 is a prime? Wait, no, 13. Yeah, 13 is definitely a prime. Okay, wait. So multiples should start at 2. It shouldn't start at 1 because 1 you're guaranteed. Yeah, my bad. Yeah, okay. And then you do multiple plus equals 1, and then that will build out your array. And then every time it comes back out here, it resets multiple, and then you just, yeah, this should, let me print the R to see what I'm looking at. At the end, this should be good though. Oh no, I misspelled it. Okay, so 2 is a prime, 3 is a prime, 4 is not a prime, 5 is a prime, 7 is a prime, and 8 and 9. Yeah, that looks like it's working properly.
Okay, but can this be optimized?
Yes, probably. Optimize space-wise or time-wise?
Time-wise. Space you have to allocate up to it, right?
I believe the space-wise is you only have to loop up to like square root of n or some shit like that, or was it divided?
That is correct. But why is that?
I forgot the reason. It was like a math reason.
Okay. So let's say you wanted to find all the primes under 16.
Okay.
Right. So can we put 16 as the...
Oh, as the test case? Yeah, sure.
Okay. So if you go through 2s, what will the array look like?
If you go through...
Or, I guess, start with the whole array and then edit it in place until it becomes the output.
So you mean print it out?
Yeah, just do an exercise.
Oh, okay. You mean just like write it out? So yeah. So if it starts with all 1, well, it's technically it started with 0, 0, and then 1s. I think it was. Wait, so it should be 14 ones? No, 13 ones.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so if you did 2s, you left this one alone, but the fourth one you flip the fourth one, you flip the 6, you flip the 8, the 10, 12, and 14. Did I miss one? Yeah, so 2, 4, 6, 8, 10, 12, 14. No, the last one doesn't count because it's supposed to be less than, right? It's only supposed to go up to 15. Okay. Yeah, so that's what happens with 2s. And then when you do 3s, you leave that one alone. And then 3 times 2 is 6. I believe this one is 6, right? No, wait. 0.
Well, 6 is already accounted for because 2.
Oh, yeah, 2 removed it. Yeah, that's why. Okay, I got it. Yeah, so that one was 6. Then you got 9, which is, this is 7, 8. This one's 9. And you got 12. The 12 is already done by 2. And you got 15. 15 is the last one. So that gets zeroed out. And then you got multiples of 4s. Wait, 0, 1. Wait, this is 2, 3, 4. So 4 is here. Okay, so 8's already done. Actually, no, 4 doesn't have anything to do because 2 already got rid of all of them. So 4 is done.
Right. Well, there's another way to optimize now, right? Like if what you start with is already 0, that means something already got it, which means that all multiples of it should also be got.
Okay, so in your range loop, so you check if that I is already 0, then you just do continue or something.
No, so you check if R of I is.
Yeah, if R of I is 0, then do not do the while loop.
Sure, or you can check that if R of I is 1, then do everything else.
Oh, yeah, that's smarter. Okay. So if R of I equals 1. Okay. Oh, right. Yeah. Okay. That's one optimization. Okay, so 4 is done, then you do 5s, which is this one. And then 10, that's already handled by 10. I mean, the 10 is already handled by 2. And 15 handled by 3, so you have nothing to do here. And then you do 6s. 6s are already all handled by 2s, and it's, yeah. So then and then you do 7. 7 is 14. 14 is already handled by 2. 8 goes to 16, and it's out of bounds, so you don't do it. 9, 10, yeah, you just do all those. Those are already all done at that point.
So you might have noticed that like even 5 was done already. Everything 5 after 4 onwards was pretty much already done.
Yeah.
So why was that?
So, what'd you say?
Why is that?
Why is that? Okay, so because 2 handled all of 2 stuff, and then 3 handled all of 3 stuff. 4 handled 4 is already done by 2. 5, yeah, 5 was handled by 3 also. So it's because 2 and 3 already did all the work. It's because is it like common multiples of not sure.
Not quite. So 2, let's say you want to reach 16, right? Then 16 is 2 times 8.
Yes.
I mean, that means from range of 1 through, 1 through 8, you'll cover all of those, right? And then it's going to be 3 times whatever 16 over 3 would be, right? And then 4 times whatever 16 over 4 would be, which is 4, right? So by the time you reach the same number, you will have dealt with everything below that. Oh, sorry. By the time you reach that number, then everything above that has already been reached.
But wait, what do you mean by the time you reach that number? What number are you talking
about? So you're iterating from 2 to 3 to 4 to 5, da da da.
Right, yeah.
So basically, if it was multipliable by one of these guys, you would have handled it earlier. The only things that you haven't checked so far are up to that square root.
Yes, but how do you know that? How do you know that it was the square root? Like, how do you know? that it was.
Okay. So we check 2 first. And we're like, okay, 2, 4, 6, 8, 10, 12, 14, right?
Yeah.
Then we check 3 is 3, 6, 9, 12, 15, right?
Mm-hmm.
Then we check 4, which is 4, 8, 12, 16. Right?
Yeah. Yeah.
When we check 5, right? Something smaller than 4 must have multiplied by 5 to get you 5 and 10 already, right? So it's like you can either come at it from below or from above, and then the sweet spot in the middle is the square root.
Yes. I just don't understand. So yeah, I knew it was square. I just don't know why. But like, if you run through the examples, you can tell that you're done at 5, or like even before you're done at 3 actually. But the problem is.
Well, no, you're not done at 3. You're done at 4.
Well, no.
Technically, if you.
Well, you're done at 4. You're done at 4 because 2. No, you're done at 3 because 2 already handled 4. You don't even need to go to 4.
Well, no, in this case, yes. But what if it was count prime to 25? Right?
Oh, you're saying.
You just skip the 25.
No, but everything that 4 does, 2 already did, right?
In this case, that is the case.
No, but I'm saying in any case, is there a scenario where 2 doesn't handle a 4?
I think you're looking at the wrong thing. That's not what you should be focusing
Oh
on.
no, I'm not focusing on it. I'm just saying that it doesn't seem like. It seems okay. Wait. Obviously, in later cases, you need to go above 5 or something, right? But then I'm saying like in the current case.
In the current case, which is 16, you should check 4 also, but 4 was dealt with.
Okay, I'm saying you should check it because it is a square root, but I'm saying. Okay, fine, that's fine, but I still don't understand the reason why it is the square root.
Because in the square root of that, you do that thing that many times, right? So if the goal is to reach n,
Yes.
okay, you can reach it. What are the factors of 30? Let's say, right?
Mm-hmm.
It's not all pairs of factors of 30.
Okay, like 15, 2, 5,
Yeah, let's
6,
follow that.
5,
1
6,
times 30, 2 times 15, 3 times
10.
Just list them out.
Oh, you mean write it out? Oh, okay. So you got 3 times 10.
You do it in order.
Huh?
You do it in order.
What is considered order? Starting from 1?
Yeah, starting from 1.
Okay. Yeah, that's all of them.
Right. So when you did the first half, which is up to the square root of 30, you do 1, 2, 3, and 5. And the other guy is already accounted for. Right?
All right, because they're the partners of it. Yeah, I see.
Exactly.
Oh, so basic. Oh, so okay. So what's the square root of 30? Is it like a bit more than 5?
So you should only check up to the square root of that number, and you're pretty much guaranteed that if you check everything up to that point, all of the lower pairs should be found.
Yes, no. But then, is the square root of 25 is 5. Square root of 30 is a bit more than 5, right? So basically,
Yeah.
so you would check because you want to be in the range of square root of n. Square root of 30 is like 5 point something. So I guess if integer, it would just round to 5. Okay, so I see. And then it would just do 1 to 5.
Right, but the range of 5 doesn't include 5, so exactly.
Oh, right. So you have to do square root of n plus 1?
The int of that.
I see. Wait. Oh, you have to cast it as an in also?
Yeah, you get some floats.
Oh, square root is float. Okay. Okay, I see. Yeah. This makes sense after you list it out. Basically, yeah, because all the lower numbers are already paired up with the bigger numbers, you don't need to do the bigger numbers again.
So when you reach up to the square root of that number, you pretty much handle the root.
Yeah, I get. All right, that makes sense. Okay, so then I would be modifying this to be int squirt of this, and then all this plus 1.
I don't know if squirt is a thing. So I think our 0.5 is.
Oh, okay. So pow.
I think I don't know. Double star is power. Oh, you can do that.
Oh, okay. Just double start.
Oh yeah. I guess that's.
Okay, so you're doing pow of n to 0.5, and then you're casting in on it, and then plus 1. That should do it, right?
Okay.
Does that still work? Oh no, this is not gonna work because of this stuff. Oh no, I have some issues here. Is this bracket not closed? Oh, I need a second one to close the range. Okay. 1, 2, 3, 4, 5. Yeah, so it did that. Okay, so I just need to sum the array and return it.
Yeah.
Alright, cool.
Issue.
Oh.
What happens when you give in 0 or 1?
When you give it what?
0 or 1.
0 over 1. Oh, you mean input. Input 0 or 1. I see, okay. So if you put 0, that means less than 0. You can't have anything less than 0. That's negative. So that one, there are no primes. And for 1, neither 0 or 1 is a prime, so that means also there's nothing there too. So I guess if it's 0, 1, return 0. That should work, unless there's a better way to handle that. Is that fine?
You tell me.
I mean, it works. I'm saying, is there a more elegant way to handle it? Oh, okay.
Are you so skeptical?
No, I know it works. Except I'm just saying, like, typically you don't want edge case handling and then do the else. If there's a better way to do this that's cleaner, you should probably do that, right? But that's fine, I guess. Alright, do you have time for more or not?
Sure. Not at this time. I should leave soon.
Oh no, that's fine then. Alright, then maybe later, or if anything, but I might be Horton later. Maybe I'll just go review. I'll review some of my questions then. Thanks.
Okay.
Alright, bye.